Hello everyone, welcome back to Tutorial Zone. I'm Said Piri as usual, and in this video we're just going to go over one last question on Earth geometry, just to remind you guys and solidify on some points that were missed in the previous videos. So in this video, what we're going to look at, just two questions. I'll just say three. Part two has got two questions there, so making it three. We're going to look at the difference in longitude between A and B. We're also going to calculate the distance between C and D, distance between C and D along the equator in nautical miles. We're also going to calculate the distance between B and D along longitude NBDS, along that longitude in kilometers. Then we've been given pi as 3.142. We've been given our radius at 34.37 nautical miles or 670 kilometers. So we'll use that depending with what the question wants us to do. Okay, so before we solve this question, before we discuss on how we can solve this question, there are things that I have to explain that we didn't actually explain in the first video, because it was left out on purpose because of this same question. And the things that I want to talk about first are the meridians. Now, if you remember, in our first video we talked about great circles and small circles, and I said that great circles are those imaginary lines that have their center at the center of the earth. And we said all longitudes are great circles, whilst in the latitudes only the equator is a great circle. Now what you should know is that these meridians are actually great circles that pass on both poles. So all longitudes all longitudes which are great circles are known as what? Meridians. So for example, this line passing on this north pole as well as on the south pole will be known as a meridian. Now, one of the most important meridians that I want you guys to remember is the Greenwich meridian. This meridian passes actually this line that is passing on both North Pole and South Pole. It's actually a longitude. It passes in Greenwich, London. The Greenwich in London. That's why it was known as Greenwich meridian. It actually holds a degree of 0. The other important line that I want you to remember as we're talking about this question here is the equator itself. It's not actually a meridian. So this equator, which is here, holds a degree of 0 degrees as well in latitudes. So it's actually latitude, while the Greenwich meridian is actually a longitude. Now, the other thing that I'll talk about, which I talked about in the first video, the fact that longitudes are imaginary lines that run from north to south, while latitudes run from east to west. We already discussed what that is. But now, instead of us using that definition, what we're going to use here is this. Longitudes, any angle between Greenwich meridian, which is I'll write it as GM, and any great circle subtended at the center. Now, what this means is that for longitudes, it will actually be any angle. Suppose this is my Greenwich meridian. This is my Greenwich meridian, and this one is my longitude. So this longitude will have a degree of that angle that will be between this Greenwich meridian and the degree and the longitude itself, which I'll put as x. So if this is the center of the earth, the angle that will be between this Greenwich meridian and this longitude here will actually be the value for this longitude. Supposing this is 30 degrees. Supposing this is 30 degrees. So this angle that is formed at the center, which is 30 degrees, will actually represent the value of this x longitude. Will actually represent the value of this x longitude. So what we mean is that the angle is formed, which is subtended here. Subtended means formed at a particular point. The angle that is formed at the center between the Greenwich meridian as well and that longitude you're talking about will actually be the same value for that particular longitude. So my point here is that for you to get, when you have been given such a model, for you to get the value of the longitudes, you first have to locate the Greenwich meridian. In this case, my Greenwich meridian is here. So once I locate the Greenwich meridian, start from the Greenwich meridian. Let's start moving from the Greenwich meridian to the center, and from the center to that particular longitude that you want to get the value for. The angle formed at the center here, because it's saying subtended at the center, the angle formed at the center will actually be the value for that particular longitude you're talking about. So supposing we have another longitude this side, and from here to there it's 15 degrees. From here to there it's 15 degrees. So this means that for you to get for longitude y, you start from the Greenwich meridian, go to the center. From the center you go to that particular longitude. You will realize that the degree that we're talking about is from here to there. Which means that 30 plus 15 degrees, you end up having 45 degrees for this particular longitude. So in other words, what we are saying is that for longitudes, you follow these angles that look like this. For these angles that look like this, the angle in between here is the value of that longitude. If this is my Greenwich meridian, it will be the value for this longitude. If this is my Greenwich meridian, the angle in between here will be the value for this longitude there. Okay, so with that said, now let's look at latitudes. So we can define this as any angle in between the equator and any small circle. Remember, latitudes are small circles, they're not great circles. Any small circle subtended or formed at the center. That's the guiding thing, to always be at the center. So what we mean here is that for you to get the latitude values, for you to get the value of the latitudes, you first have to locate the equator. So supposing this is my equator, this is my latitude there, and there's another latitude here at the bottom, and this is where my center is. So for you to get the value of, let's take the the top one to be x and the bottom one to be y. So for you to get the value of latitude x, you first have to locate the equator, because it has to be between the angle should be between the equator as well as any small circle. In this case, our small circle is latitude x degrees there on top. So we always have to start from the equator, go to the center, from the center, go there. Supposing this is 45 degrees. This is 45 degrees. This means that latitude x is 45 degrees, because according to the definition of latitude here, we're saying any angle in between the equator and any small circle subtended or formed at the center. My center is here, my center of the earth is there, and this angle is in between the equator here and x degrees, actually lying parallel to each other. So the angle in between these parallel imaginary lines, which are the equator and x degrees, will actually be the value of x degrees. If it was for y, it should be from the equator to the center, to y there. This angle to be formed there will actually be the value for y degrees there. So what we are saying here is that when getting the values for latitudes, you should follow these angles that look like this. The angles that look like this. For those angles that look like this is for the longitudes, while these are for latitudes. So you should look at these for latitudes, and you look at this for latitudes. Okay, now that we have talked about how to find the angles and where to get them, what we're now going to do is we're going to now look at the questions that were set for this particular period, for this particular diagram there. So in this question they are saying A, B, C, and D are actually points on the Earth's surface, and they want us to, in the first question, they want us to find the difference in longitude between A and B. They want us to find the difference in longitudes between point A and point B. So if you remember in our first video as well as the second video, I said that when finding the difference in longitudes, what you have to do is first check out those 2 points. Point A is here, point B is there. So you should ask yourself, is point A and B on the different sides or on the same side of the Greenwich meridian? In this case, A is on the Greenwich meridian itself. So Greenwich meridian, the value is 0 degrees. We mentioned that already. Let's look at the value for B, longitude where B is. So what we should do is, we'll go on the Greenwich meridian. Go to the center. From the center, go to the longitude that we're talking about, which is this longitude here, where B is. The angle formed in between these two longitudes will actually give you the value of this longitude where B lies. This longitude where B lies, the value will come from this angle. And this angle they are saying is 52 degrees. It's 52 degrees. And this should be west, whilst this should be east. So 52 degrees west. So in this case, since Greenwich meridian is actually doesn't have west or east, you can either add or subtract to find the difference. So difference between A and B will actually equal to 52 degrees west plus 0 degrees. So you have 52 degrees as our difference between A and B. We have that as our answer there. Because where is the 0 degrees coming from? The 0 degrees comes from the fact that where A lies on the Greenwich meridian, and the value for that is 0 degrees. But what should you remember when finding the difference in longitudes or latitudes is that for finding the difference in longitudes, those points that lie on the same side of the Greenwich meridian are subtracted, while those points that lie on different sides of the Greenwich meridian are added. The same for latitudes, those points that lie on the same side of the equator are subtracted, while those that lie on different sides of the equator are added. Okay, so now what we're going to look at is the second question, which tells us to find the distance between C and D in nautical miles. Telling us to find the distance between C and D in nautical miles. Now, what I said before finding the distance is that first look at where C and D lie. C and D lie on the same latitude. And I said that if points are lying on the same latitude or on the same longitude, that means that you are finding the distance in that particular latitude or longitude. In this case, these points are lying on the equator. These points are lying on the equator, and that means we are finding the distance along latitude of the equator, which is 0 degrees. And the formula for finding distance, which is distance CD here, is equal to theta over 360 degrees multiplied by 2 pi r. You can use this 2 pi r even if you're finding the distance along the latitude, which is the equator, because the equator is a great circle and it has the value of 6,370 kilometers or 3437 nautical miles. So if you want, you can also use the formula for finding the distance in latitude, where you can put cos x degrees here. So we can also follow that, which we're going to use in this video. But what you have to understand is that for the equator, you can actually use 2 pi r. It's okay because the value for r will be that equal to the value of the equator. Sorry, because that equal to the value of the Earth's radius. Because the equator is a great circle. But you can also use this value, you still get the same. You can also use this formula, sorry, you still get the same answer. Now, let's find what theta is. I said that theta, when finding the distance in latitudes, theta is a difference in longitudes. So we've already calculated difference in longitudes here. We could say this is longitude 52 degrees west from this angle formed at the center there. We say that's 52 degrees west, and we say this is 0 degrees. And from our previous question, we have found that the theta there is 52 degrees. So let's put in the values. CD is equal to 52 degrees over 360 degrees multiplied by 2 by 3.142 multiplied by, here we're finding nautical miles, so we use 37 nautical miles multiplied by cos x degrees will be the particular latitude that we're talking about. Here we're talking about the equator, so x will be 0 degrees. CD is equal to, when you do your calculations there, 2 over 360, you'll get 0.14444 multiplied by 2 multiplied by 3.142, you have 6.284. Then cos 0 there is 1. Cos 0 is 1 there, so there's no need for us to write it. Anyway, we'll just put it there, but just know that cos 0 is 1. So CD is equal to, we're going to say 0.1444 multiplied by 6.284. We want to have 2486. If our calculations are correct, then this should be our answer there, 0.9024. Sorry, 0.902 nautical miles. That should be our answer there. Let me just go through it again. Sorry, we have actually left out 3437 nautical miles. 3437 nautical miles multiplied by 3437 nautical miles. And we have said cos 0 is actually 1. So CD is equal to 0.1444 multiplied by 6.284 multiplied by 3437. So you have 3,109.63072 nautical miles. CD is equal to 3,119.631 nautical miles to 3 decimal places. That should be our answer there. If our calculations are correct, then that's how we're supposed to find the distance along the equator. Even if you remove this cos x, use that formula for longitudes, where you take, since r is the same for the equator as well as the earth radius, you can actually use that formula. It also give you the same answer, because cos x here is 1, so it won't even change. Okay, so right now what we're going to do is our last question, which is telling us to find the distance b between b and d along longitude NBDS. This longitude here, this longitude there. So now remember, when finding the distance in longitude, we say that we use the formula for this, for finding the distance in longitude, which is distance BD is equal to theta over 360 degrees, multiplied by 2 pi r. And I said that when finding a distance in longitude, theta is the difference in latitude. So now, if you look at B is on this latitude here to the north, and D is on the equator. So when finding, since we're finding theta here, which is a difference in these two latitudes where these 2 points lie, we need to get the value for this latitude here. We don't know the value there, but it has been given. So what do you do? I said when introducing this topic, I said you first start from the equator, go to the center, from the center go to that particular latitude that you want. Then you check out the angle that is formed in between these two latitudes. The angle formed is 52 degrees. Therefore, this latitude here is latitude 52 degrees north. If there was another latitude here and you want to get the value, you go from the center, from the equator to the center, from the center you go here, and you take out the value that is formed here. It will be the angle for this particular latitude there. So we have found that it's 52 degrees north. So B and D, since the equator is 0 degrees, you can even add, just find the difference or subtract it to still give the same answer. So you have that there. Theta is equal to 52 degrees there. Since we know our theta now, we can go ahead to find the distance. BD is equal to 52 degrees over 360 degrees multiplied by 2 by 3.142 multiplied by, we're finding this in kilometers. So instead of using 3437 nautical miles like previous, we say 6,370 kilometers. So distance BD is equal to, let's calculate there. You say 52, you have 0.1444 multiplied by 2 multiplied by 3.142 multiplied by 6,370. You have 40,000 multiplied by 40,000 and 29.08 kilometers. This multiplied by 0.1444 to give us the distance of distance is equal to 5,780.199152. We write this to 3 decimals. Distance is equal to 3 decimal places. You have 5,780.199 kilometers. So your calculations are correct. If our calculations are correct, then this is how you find the distance along NBDS. So with that said, this wraps up our video and our examples on earth geometry. You should look out for the coming topics. You can also suggest for those particular topics. Then you can actually comment You also can also like, share, as well as tell your friend to tell a friend. This might help someone else in future, and we'll be grateful if you can actually do that. So just look out for coming topics.